Understanding the boot process. Knowledge is power. The better you understand what happens when you fire SD turn on a computer until Windows is loaded and the Windows desktop appears, the more likely you will be able to solve a problem when Windows cannot start. Let's begin by noting the differences between a hard boot and a soft boot. Choosing between a hard boot and a soft boot. The term booting comes from the phrase lifting yourself up by your bootstraps and refers to the computer bringing itself up to a working state without the user having to do anything but press the on button. This boot can be a hard boot or soft boot. A hard boot, or cold boot, involves turning on the power with the on/off switch. A soft boot, or warm boot, involves using the operating system to reboot. A hard boot takes more time than a soft boot because in a soft boot, the initial steps of a hard boot don't happen. To save time in most circumstances, you should use the soft boot to restart. A hard boot initializes the processor and clears memory. If a soft boot doesn't work or you want to make certain you get a fresh start, use a hard boot. If you cannot boot from the operating system, look for power or reset buttons on the front or rear of the case. For example, one computer has 3 power switches, a power button and a reset button on the front of the case and a power switch on the rear of the case. They work like this. The power button in front can be configured as a soft power button, causing a normal Windows shutdown and restart. The reset button initializes the CPU so that it restarts at the beginning of the BIOS startup program. The computer behaves as though the power were turned off and back on and then goes through the entire boot process. The switch on the rear of the case simply turns off the power abruptly and is a hard power button. If you use this switch, wait 30 seconds before you press the power button on the front of the case to boot the system. This method gives you the greatest assurance that memory will clear. However, if Windows is abruptly stopped, it might give an error message when you reboot. How the front 2 buttons work can be controlled in BIOS setup. Know, however, that different cases offer different options. Startup BIOS controls the beginning of the boot. Recall that the startup BIOS is programming contained on the firmware chip on the motherboard that is responsible for getting a system up and going and finding an OS to load. A successful boot depends on the hardware, the BIOS, and the operating system all performing without errors. If errors occur, they might stall or lock up the boot. Errors are communicated as beeps, as text messages on screen, or as recorded voice messages. Startup BIOS is responsible for these early steps in the boot process. 1. Startup BIOS reads motherboard settings and runs the post. Here are a few important details. A small amount of RAM on a firmware chip on the motherboard holds an inventory of hardware devices, hardware settings, security passwords, date and time, and startup settings. Startup BIOS reads this information and then surveys the hardware devices it finds present, comparing it to the list kept in this RAM. B. Startup BIOS runs post, power on self-test, which is a series of tests used to find out if startup BIOS can communicate correctly with essential hardware components required for a successful boot. C. Before the video controller on the motherboard or video card is tested and configured, startup BIOS communicates any errors as a series of beeps or recorded speech. Short and long beeps indicate an error. The coding for the beeps depends on the BIOS. After startup BIOS has checked the video controller, note that it does not check to see if a monitor is present or working. It can use video to display its progress on screen. 2. Setup BIOS might be run. The keyboard is checked, and if the key is pressed to request BIOS setup, the BIOS setup program is run. For example, for one system, when you press L, the BIOS setup opening menu shown in Figure 14.2 appears. You can use the menus and items on these screens to verify hardware devices recognized by the system, enable and disable devices, set the date and time, set security passwords to the computer, change the boot device order, and make other changes to BIOS settings. Know that the screens provided by different motherboard manufacturers might be organized differently. 3. Startup BIOS searches for a bootable device. The boot sequence stored in CMOS RAM tells startup BIOS which device to use to launch an OS. Most BIOSes support booting from the hard drive, a CD or DVD, a USB device, or another computer on the network. Older computers could also boot from a FLP disk. The BIOS turns to the specified device and turns control over to it. Next, let's see what happens if the device is the hard drive. Steps to start Windows 7/Vista. Table 14.1 lists the components and files necessary to start Windows 7/Vista. Startup BIOS turns control over to the MBR program stored in the FireSD sector of the hard drive. 2. The MBR program searches the partition table looking for the active partition, which Windows calls the system partition. It finds and loads the Windows Boot Manager, bootmgr, program in the root directory of this partition. Note that the bootmgr program file has no file extension. If the MBR program cannot find bootmgr or cannot turn over operation to it, one of these error messages appears. Missing operating system. Error loading operating system. Windows failed to load. Invalid partition table. 3. Bootmgr does the following: A. It reads the settings in the boot configuration data, BCD, file. B. The next step, one of 5E, depends on entries in the BCD and these other factors. Option 1, for normal startups that are not dual booting, no menu appears in bootmgr finds and launches Windows bootloader, winload.x, stored in the /Windows/System32 folder. Option 2, if the computer is set up for a dual boot environment, bootmgr displays the Windows Boot Manager screen, as shown in Figure 14.5. Option 3, if the user presses the spacebar, the Windows Boot Manager screen appears. Option 4, if the user presses F8, bootmgr displays the Advanced Boot Options screen, as shown in Figure 14.6. Option 5, if Windows was previously stopped abruptly or another error occurs, the Windows Error Recovery screen. WinLoad is responsible for loading Windows components. It does the following: A. For normal startups, WinLoad loads into memory the OS kernel, taskkernel.x, but does not yet start it. WinLoad also loads into memory the hardware abstraction layer, HAL.dll, which will later be used by the kernel. B. WinLoad loads into memory the system registry hive, C:\Windows\System32\config/system. C. WinLoad then reads the registry key just created, key_local_machine\system\services, looking for and loading into memory device drivers that must be launched at startup. The drivers are not yet started. D. WinLoad reads data from the key_local_machine\system key that tells the OS if the user wants to start the OS using the last known good configuration. E. WinLoad starts up the memory paging process and then turns over startup to the OS kernel, taskkernel.x. 5. The kernel, taskkernel.x, does the following: A. It activates the HAL, reads more information from the registry, and builds into memory the registry key_local_machine\hardware, using information that has been collected about the hardware. B. The kernel then starts critical services and drivers that are configured to be started by the kernel during the boot. Recall that drivers interact directly with hardware and run in kernel mode, while services interact with drivers. Most services and drivers are stored in C:\Windows\System32 or C:\Windows\System32 / drivers and have an X, DLL, or sys file extension. C. After the kernel starts all services and drivers configured to load during the boot, it starts the session manager, smss.x, which runs in user mode. 6. The session manager, smss.x, does the following: A. It starts the part of the Win32 subsystem that displays graphics, and the Windows 7 flag or the Vista progress bar is displayed. See Figure 14.8. When you see the flag or progress bar, You know the Windows kernel has loaded successfully. B. SMSS.exe then starts the client, server runtime subsystem, CSRSS.exe, which also runs in user mode. CSRSS.exe is the Win32 subsystem component that interacts with applications. C. SMSS.exe starts the logon manager, winlogon.exe, and reads and executes other commands stored in the registry, such as a command to replace system file A placed there by Windows Update. 7. winlogon.exe does the following. A. It starts the service control manager, services.exe. Services.exe starts all services listed with the startup type of automatic in the services console. B. winlogon.exe starts the local security authority process, lsas.exe. The login screen appears, see figure 14.9, and the user account and password are passed to the lsas.exe process for authenticating. The last known good configuration information in the registry is up. That will be all for this video, so be sure to hit that like button and subscribe to CTech and enable that bell icon so you don't miss any further videos with us.